Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet Unit 3B, probability distributions, and this will be problems 61 through 70. So the distribution of the amount of a customer's purchase at a convenience store is approximately normal with a mean of 1550. We know that's important. And a standard deviation of 1.72. Which of the following is closest to the proportion of customer purchase amounts between $14 and $16? So we're looking for the probability that 14 is less than X is less than 16. Now there's two ways to do this. I'm going to do this a long way first just because I think it's important to know how to do it. I'll get my calculator on. Here we go. We're going to go to stat test and we're going to run a z-test. And our mean, they said, was 1550. Our standard deviation was 1.72. And we are going to start off with the 16. And by the way, just real quickly, I should draw a picture of this. The mean is 1550. Here's the 16, and the 14 is a little bit below it. And we're looking for that distance. So I'm going to start with the upper one, and I'm going to subtract the lower one. So, and we only have one. I want to make sure that I have less than, because that's what I have in my probability statement. And I end up getting 0.6143. So 0.6143, and we're going to have to subtract out the 14. So here we go. We're going to go back and run it again, but this time with a 14. And we get 0.1915. So let's subtract those two probabilities. 0.6143 minus 0.1915, and we end up getting 0.4228. And our closest answer on that happens to be C. Now, there's a shortcut to it. You could have gone second vars, norm CDF, and our lower bound, our lower bound was 14. Upper bound is 16, mean of 15.5, and standard deviation of 1.72. This is much faster for this type of problem, but there's sometimes you can't do it this way. And the other way you can always do. So here we go. 0.42. The yearly average rainfall along the coast of Liberia is 210 inches. So they're telling me the mean is 210. What is the standard deviation if 20% of the years have rainfalls under 200 and rainfalls are normally distributed? All right, so we have, this is not a standard deviation. This is an X value. All right. And they're asking for the standard deviation, but X is 200. And let's draw a picture to see what we have. Well, we know we have a mean of 210. We know we have an X of 200. And we know that this area right here is 0.20. So I'm going to go to my z-score, and z equals x minus mu over sigma, and plug in what I have and see what if I can figure something out. So what I have is I have x at 200 minus 210. They asked me to find standard deviation, so I know I don't have that. And I don't have my z-score, but I do have 0.20. And if you remember, I can go to second vars, inverse norm, and press 0.20. Remember, all z-scores have a mean of 0, standard deviation of 1, and we end up getting negative 0.8416. At this point, I can use a little bit of algebra, and when I rewrite this, I'm going to bring this up and this over, And I should have scooted over, so I'll write this over here, but this is going to go this, these are going to swap places right here. So 200 minus 210 is negative 10. That's be my numerator over, and the standard deviation is going to, because I'm moving this over and this goes underneath, negative 0.8416. So negative 10 divided by the negative 0.8146, and I get about 11.88 inches. So my best answer choice is C on that one. All right. The diastolic pressure among 20 to 30-year-olds is roughly normal. Okay. If 10% have levels above 86 milligrams and 20% have levels below 69 milligrams, what is the mean of the distribution? Now, this is a really difficult problem because they don't give you the mean or the standard deviation. So I can't go straight to this. And this actually ends up being a system of equations. And to speed this up, I started with the drawings and then we'll go from there. Okay, so, and I hope I actually numbered these correctly because I have a couple of these in this particular one. 20% and 10%. I actually misnumbered them, but that's okay. Here we go. So this happens to be number 63. So looking at the drawing, they said 10% have levels above 86. And by the way, whenever they have problems like this, I like to draw an X and I go, oh, the 10%. They said it's above it, so that means the 10% is up here. So I draw my normal curve and there's 10%. That means my lower portion down here is 90%. My mean, we don't know, but we know the X value was 86. So that's my picture. All right. Now I can go Z equals X minus mu sigma. And it's like, well, I don't know that, but I know the Z is associated with either 90 or 10. It doesn't matter which way you go about it. But second vars, inverse norm, 0.9. If I use the 0.9, and remember all Z-scores have a mean of 0, standard deviation of 1, then I need to be to the left. And I press enter, and I get 1.218. And that makes sense that it's positive because it's up here above the mean. Now, if I had gone second vars, inverse norm, and used 0.1, which is the value they actually gave me, then I'm on the right-hand side, and I'll still get the same thing, but it's make sure that you have the correct left and right. So the picture really helps with that. The next thing, 20% have levels below. So once again, I put the X and it's like, oh, the 20%, that's on the low side. So that's down here. Well, once again, I plugged in and I go, there's my 69. There's my mean, the standard deviation I don't know. And I did a 20% Z-score. So second vars, inverse norm, 0.2. And if you notice, I'm shaded on the left-hand portion of the graph. So I had to have left here. And I ended up negative 0.8416. Well, when I look at that, it's like, hey, I have two equations, and the mean for each one are the same. The standard deviation for each one is the same because they're coming from the same distribution. So I have two equations, two unknowns. I can solve by systems of equations. So the first thing I need to do is multiply by the standard deviation. I do that, and this looks like this. I do that, and this looks like this. All right. So I'm just moving this out over here for both of them and rewrote it. Then I stacked them up. This one on top, this one below. It doesn't really matter what order. That's what I chose. And so now from that point on, I'm going to go, well, I need this mean to go away. If I make this a plus, which means that becomes a negative and this becomes a plus, they'll go away. So the means went away. 86 minus 69 is 17. And we have 1.2815 plus 0.8416. And we get 2.1231. 2.1231 standard deviations equals 17. Well, I'm going to take that 17 and divide it by the 2.1231. And I end up finding out, hey, my standard deviation is 8.0071. And I'm all excited, except they didn't ask me for standard deviation. They asked me for what is the mean of the distribution. So I've got to go a little bit farther. Doesn't matter which equation I choose, I can um, plug in and solve for the mean. So I'm just going to plug into this one, and I have 1.2815 times the standard deviation we just calculated equals 86 minus the mean. So times 1.2815, I get 10.26. 117 equals 86 minus the mean. I'm going to subtract 86 from both sides. And I get 75.7388, a negative 75.3788 equals a negative mean. I can swap the signs and I end up with a positive. So let's check to see what we have in the way of answer. And when I look, I go, well, I don't exactly see my answer. I see 75.7. That's probably my closest answer. So my answer choice is B. All right. My answer choice is B because that is the closest that I can get with this one. Going to be due to rounding that we got that we got a different answer, but that is correct. Okay. So that's the way you approach that problem. That's one of the hardest problems there is, and in this video we'll have 3 type problems that are like this. Number 64, apples growing in a certain orchard have weights that are normally distributed with a standard deviation of 2.2. All right, so we have a standard deviation of 2.2. What is the mean if 80% weigh less than 9.1? So once again, we have X, and it says 80% weigh less. That means it's over here. All right, so my 80% is down here. So when I draw my picture, this is a little bit different. We don't know the mean. We know that I need 80%. That's over halfway, so that's going to be this way. And this is 9.1, and that's my X value. So let's go back to our organizer, Z equals X minus mu over sigma, and start plugging in what we know. Well, we don't know the mean, all right? So we don't know the mean, but we do know the 9.1. So we have 9.1 minus the mean over, they gave us a standard deviation of 2.2. Well, I don't have a z-score, but I can get it by doing the inverse norm. So second vars, inverse norm, and we have 0.8. And notice we shaded from the left, so I need to have left highlighted on the calculator. And I get a positive 0.8416. All right, I'm going to multiply by 2.12. That'll get rid of this, or 2.2. Times 2.2. So now I have 1.8516 equals 9.1 minus mu. Subtract 9.1 from both sides. And I have a negative 7.24. 8 equals a negative mu. Make them both positive. And the closest answer, oops, that should be positive. The closest answer to that is A. So 64, I'm coming up with A. 65. A statistician at a metal manufacturing plant is sampling the thickness of metal plates. If an outlier occurs within a particular sample, the statistician must check the configuration of the machine. The distribution of metal thicknesses has a mean of 23.5 and a standard deviation of 1.4. All right. Based on two standard deviations rules. So in other words, if it's two standard deviations above, so mean plus or minus two standard deviations denotes where the outliers are. So if we were looking at a curve, we said the mean was here. We have this would be 0, 1, 2, 3, 1, 2, 3. Anything this -2 below or 2 this way, anything in this area, those two areas are outliers. So based on the two standard deviations rule for the following, which is the greatest thickness? Oh, that's going to be tricky here. That would require the statistician to check the configuration of the mean. So let's go 23.5. 23.5 plus 2 times our standard deviation is 1.4. 23.5 plus 2 times 1.4. And we get 26.3. All right. So x greater than 26.3, that's an outlier. There's no number bigger than 26.3. Not an outlier, not an outlier. So, we got a problem. So let's try this. Let's see if we can go 23.5 minus 2 times 1.4. 23.5 minus 2 times 1.4. And we get 20.7. So if x is less than that, it's an outlier. So x less than 20.7. Oh, I have two values that qualify. Both of those are less than 20.7, but they gave us something else. Which one has the biggest thickness? Oh, B. B is thicker than A. So both of them are outliers, but the one with the greatest thickness is B. So my answer choice for number 65 is B. All right. As I said, we had a couple difficult problems on this one, and here comes another one. Actually, we have three really difficult problems. We've done one. This will be number 66. Will be the next one. Suppose the weights of trucks traveling on the interstate highway system are normally distributed. If 70% of the trucks weigh more than 12,000 pounds, and 80% weigh more than 10,000 pounds, what are the mean and the standard deviation for the weights of the trucks traveling on the interstate system? Well, here's the deal. They didn't give us a mean or standard deviation, so that makes this a little bit difficult. So, once again, the pictures themselves are tricky too. 70% weigh more. So anytime they do that, they give me a question like this, I always put an X and I go, oh, 70% is above it. That means I'm shading from above. I'm shading from the right. That means this is 0.3. And they said that that's 12,000. I don't know my mean. Over here, 80% weigh more. Oh, well, again, put my X, my 80's up here. So I'm shading from the right. And this time it's 10,000. All right. Now, these are the same types of trucks, the same highway. The means and standard deviations are the same. So we'll start plugging in. And there's my formula, Z equals X minus mu over sigma. And I go, okay, I have 12,000 for my X. I don't know my mean. I don't know my standard deviation. And I can go second vars, inverse norm, 0.3 and go from the left. And I get negative 0.5244. Or I can go second vars, inverse norm, 0.3 and go from the right. And I'll still get the same, not 0.3, 0.7. And I'll still get the same thing. So you can do it either way. Just make sure you're careful that you have labeled this out nicely so you'll know what you're doing. All right. On the other one, it's like, well, I know the 10,000. I don't know my mean. I don't know my standard deviation, but I know 20%. Second vars, inverse norm. which means I have 80% above. So 80% coming from the right, and that gives me negative 0.8416, or I can go second vars, inverse norm, and go from the left, but that becomes a 20% at that point. All right. So make sure you have your left and rights correct. So once I have that, I'm going to do a little bit of algebra, and I'm going to move this here and move this here because lo and behold, I have two equations and two unknowns, so I can solve by systems. So I'm going to move this up by multiplication, and I get negative 0.5244 standard deviations equal 12,000 minus mu. And when I do the same thing here, moving this up, negative 0.8416 standard deviations equals 10,000 minus the mean. I wrote them down, and just one on top of the other. Which point I'm going to combine by eliminations because I can get the means to drop off by flipping all the signs on the lower one. So when I do that, I have negative 0.5244 plus 0.8416, and that equals 0.3172. 12,000 minus 10,000 equals 2,000, and my means went away. Oh, this has a standard deviation sign, excuse me, equals that. So now I'm going to divide both sides by 0.3172. And I get a standard deviation of about 6,305. At which point we really know our answer. All right. Because our closest answer, that's 6,300. That looks like that's it. I'm still going to plug in. It doesn't matter which one I plug into, but I'm still going to plug in just to check myself out. So I'm going to plug into this first one, and I have negative 0.5244 times 6,305 equals 12,000 minus the mean. So times a negative 0.5244, that's negative 3306 equals 12,000 minus the mean. I'm going to subtract 12,000 from both sides. This will go away. And we get negative 15,306 equals a negative mean. I can switch the signs or multiply by negative 1. So 15,306 is my best answer. And that's pretty consistent with what we have here. The answer choice to 66 is C. All right. We have one more of these challenging problems, and it happens to be number 67. So suppose that 60% of them let electronic part last over 3 years. So X, 60% is over 3. All right. So the 60% is here. So this is 3. That works there. And so that means if I'm drawing my picture, 60% is coming from the right. So 40% below. The next one, 70% less than X. So if I put an X, my 70 is down here, and we're shading below, and that X represents a 6. Find the mean and standard deviation for those parts. Well, once again, I put my organizer, my Z equals X minus mu, and I start plugging in. I know my X is 3. We don't have our mean. We don't have our standard deviation. But if I do a second vars, inverse norm of 0.4, we get negative 0.2533. And once again, just a reminder, second vars, inverse norm. I could change it to the 0.6, but I'm shading from the right at that point. Make sure it has the right, and I'll get exactly the same thing. Okay, doing the same thing for the second part, we have 70%, and we're coming from the left. So second vars, inverse norm, 0.7, coming from the left. and we have 0.5244 equals the 6. We don't know the mean. We don't know the standard deviation. Using a little bit of algebra, I'm going to just bring this up, and I'll do the same thing here, and I'll rewrite it. Because lo and behold, I have two equations. So they both have the same mean. They both have the same standard deviation because we're coming from the same distribution. And so I have two equations and two unknowns, so I can solve by systems. So I'll put this one on top because it's positive. Not that you had to, you can do either one. It'll work out. It's just algebra. And I have this one below. Okay, if I switch the signs on the lower level, all of them, then my means will go away. 6 minus 3 is just 3. And if I add up 0.5244 plus 0.2533, we end up with 0.77 standard deviations equals 3. If I divide both sides by 0.77, I should be able to get my standard deviation at this point or be close. There will be rounding because we have so many decimals. So I end up with a 3.857 standard deviation. We'll see which one is closest. So when I do that, it's like, well, 3.861. This is looking pretty good here at B. That looks like that's the closest. Let's go ahead and plug back into one of the equations to check for the mean. It doesn't matter, again, which equation. I'm going to choose this one just because it's positive, but it really doesn't matter. So 0.5244 times 3.8575 equals 6 minus the mean. So 2.0228 equals 6 minus the mean. I'm going to subtract 6 from both sides. And we get 3.977, a negative 3.977 equals a negative mean. Make them both positive, and we're good to go. And 3.977 is exactly the answer choice for B. So B is our best guess for that one. All right. 68, the distributions of weights of 16-ounce bags of a particular brand of potato chips is approximately normal with the standard deviation of 0.28. How does the weight of a bag at the 40th percentile compare with the mean weight? Okay, so first off, picture. This is my mean, and it's 16 ounces. We have a standard deviation of 0.28, and they said this is the 40th percentile. Well, remember, percentiles start at the bottom and go up. So in this case, we're going to start at negative infinity. So let's plug in what we have. Z equals X minus mu over sigma, because this is like our major organizer. Well, I don't know what X is, but I know my mean is 16. I know my standard deviation is 0.28. And I know that if I do an inverse norm, second vars inverse norm, I can get 0.4. And remember, all z-scores are 0 and 1, and this is coming from the left because that's where we're shaded. We end up getting negative 2.533. Negative 0.2533. Multiply both sides by 0.28. And I have negative 0.0709 equals x minus 16. All right. So first off, I'm below the mean. All right. And if I actually add 16 to both sides, this goes away. And we find out that we're at 15.93. How far below the mean are we? Well, 16 minus 15.93. We're 0.07 below the mean. And we know we're below the mean because we're at the 40th percentile. At the 50th percentile, we're at the mean, 60th percentile, we're above the mean. All right, so we're below the mean, and we just needed to calculate the z-score. Now, there's another way around this. It's really nice and fast. Second vars, inverse norm, area 0.4. Oh, what's my mean? My mean is 16. What is my standard deviation? 0.28. Remember, we're shading from the left, and we get 15.929 right there. So our x value is 15.929, which is less than 16. So we're 0.07 below. All right, the longevity of people living in a certain locality has a standard deviation of 14. What is the mean? We don't know it. If 30% are living longer than 75 years. So again, x, 30, so we're above it. Okay, that's important to know. So x is above it. That means we're shading from this direction. So this is 0.30. This over here is 0.70. We don't know the mean, but we know that this is 75. So once again, our organizer, z equals x minus mu over sigma. Well, I don't know the mean. I know the 75 minus the mean over standard deviation of 14. And I can do an inverse norm for 0.70. All z-scores have a mean of 0, standard deviation of 1. We're coming from the left because that's where I pulled from. So 0.5244. All right, on an FRQ, that's work shown. So let's go ahead and run this thing. Second vars, inverse norm. Now we can plug in and do it by algebra. But 0.7 mean, let's use the actual. Oh, we don't have the actual mean, so I don't have a choice. I have to do this way. So I have to multiply this times 14. 0.5244 times 14 is 7.3146. I multiplied both sides by 14. So this went away. So we have 0.73416 equals 75 minus the mean. Subtracting 75. I get negative 67.65 equals a negative mean. Multiplied by -1, they both become positive. Answer choice is B. All right, number 70. The average yearly snowfall in a city is 55 inches. Okay, so they're telling us our mean is 55. What is the standard deviation? We don't know it. If 15% of the year's snowfall is above 60. All right, so here we go. We have an X, and we're above, 15% is above 60. So the 15% is up, right? Because it's used the word above. So my picture is going to look like this. Here's my mean, which is 55. 60's here. And this area right here is 15. Z equals x minus mu over sigma. Well, we know 60. We know 55. We don't know the standard deviation. But from the 15%, we can get a z-score. So coming from the left, second var's inverse norm, I'd use a 0.85. All z-scores have a mean of 0, standard deviation of 1. So this is 1.0364. If you had wanted to come from the right, and you could have, you would have gone second var's inverse norm, 0.15. And 1.0364. We can simplify the top and we end up with 1.0364 equals 5 over the standard deviation. We're going to swap places with these two. So it's going to be 5 divided by that number. When we get 4.824, our closest answer to the 4.824 is A. So 70 is A. All right. I appreciate you watching. Hope to see you on the next one. Thank you.